Hi, everybody. So, I've been working in data warehousing, big data, this type of field for more than 15 years. And when we talk about OLAP, people have a lot of different experience and things like that. But when I joined eBay in 2004, we got a whole data warehouse of 30 terabytes, and it was already huge, right? At that moment. But now that's nothing, and people talk about data in petabytes. And with all this new data, we need new tools, new technology, new architecture, and that's where we created Kylin. So, what is Apache Kylin? The name is from an Asian, imaginary kind of animal, which means something good, good luck, and we're part of Apache Foundation, and this project is the top level project in Apache Kylin, and we're the leader of the OLAP on Hadoop, and the Apache Kylin won 2 years in a row the best open source big data tool from InfoWorld. And where does it fit in? Because with the new big data technologies, there are the whole ecosystem. There are a lot of different technologies, different components playing different roles. And Apache Kylin tried to fit in the middle between Hadoop ecosystem and all the BI, data visualization, all these kind of applications of data. So why do we need that middle layer? Because like previously we had RDBMS to store our data warehousing data, like Teradata, or some people use MySQL or SQL Server or Oracle. And then later on, we have big data technologies. People all got their own Hadoop clusters. They have much more data. It make a lot of things previously impossible now possible, right? You have a lot more variety of data, huge volume of data, and now you can do a lot more analysis on top of those. But at the same time, it creates new challenge for all the organizations that now adopt this newer technology, because the data, you can store it there, but how to get it out, how to still find the insight that you want to have, it become more and more difficult. You need engineers who knows how to program, to write the query, to process the data, to get the insight out of that system for you. I remember at the beginning when there was the NoSQL thing, and people got very excited, especially engineering community. They got very excited, and but later on, people say it's not NoSQL, it's not only SQL, because people still need SQL. And then later on, there's new SQL. So I think SQL interface is already something that has a lot of investment, and a lot of people are used to that, especially business users. And how to preserve that kind of investment, how to really still maintain the user friendliness of the big data technology is also a big challenge. So Apache Kylin in the middle, as an OLAP engine, it does several things. One thing is it simplifies how you access the data. The data will be be more democratized, and people can easily access it through different BI tools and SQL and even Excel. On the other side, a lot of times with huge data volume and the big data set, a lot of this kind of processing and query become more like a batch process. You cannot really interact with a Hive table that easily. You normally will throw a query and then wait a while and get the result. But with Kyligence, it accelerates this kind of interactive queries. It enables the business users to simply just use SQL to interact with the data set and get the result back in sub-seconds, on top of like trillions of rows. That's what Kylin can do in the middle. And that's why it finds its value propositions in the whole ecosystem. And you can see some of the cases. All these cases are based on open source Apache Kylin, because I'm from Kyligence. That's the company that make the commercial version of that and enhance it. But for the open source version, it already got a lot of adoptions, over thousands of users across the globe using the open source version. One of them is ByteDance, is a top one news app in China. And in one of their cube, one data cube, one OLAP cube, they have 3 trillion rows, and you can still get sub-second kind of query latency, maybe 90% of the time. And for some Fortune 500 companies, they also use that. And for some of the companies like Yahoo Japan, they even use it to support their website. We'll see a little bit more detail later. And on top of that, they integrate with all the BI tools, so it become more like an open platform. You don't need a special query engine or query language like Druid. Has its own, JSON format kind of query to get the data out. It just supports ANSI SQL, and you can even do joins between your fact and some of the dimension tables. So a little bit of the history. It was created in 2013 by China Development Center in China, eBase Development Center in China. And later on, it became a top-level Apache project. It's actively maintained, and our company has a dedicated team to maintain the open source version. Currently, the version is 2.4, and we're working on the 2.5. And as I mentioned, globally, there are a lot of adopters, both some maybe department for some use cases, some are actually the whole company has some of their business based on Kylin. And Apache Kylin, the high-level architecture, you can see that it fits in the middle. It has data source from both Hive and Kafka, and it will push down its cubing processing to your Hadoop cluster or Spark. And our roadmap actually will later on be wholly Spark-based, and will gradually phase out MapReduce. And on the other side, we support ANSI SQL, and all your BI tools and web application can just use the simple SQL interface to interact with the dataset in Kylin. The open source version uses HBase as its own storage, and to provide the query performance and other things people need. Our commercial version has our own proprietary kind of storage to make it even better. So in the middle, Kylin just sit there, and you also have your batch job or continuous incremental load to process your raw data and put your data into Kylin. It's more like I think this. Yeah, it's still working. Okay, and then build its cube. It's more like a materialized view. You join all your data together and then put into your. You can call it more like a huge multi-dimensional table or a cube, and then Kylin will serve that to your application. Some of the use cases. The first one, as I mentioned, is in ByteDance. It has over 600 million users. It's the top one newsfeed app in China. And for their user scenarios, the first one is their video impression data. They sell their ads also through that. And the cube by itself, the single cube can be more than like 4 terabytes. For the traditional kind of cubing technologies like Cognos or SSAS, this kind of size is not possible. And that's also why we call it extreme OLAP, because it based on the distributed kind of architecture, it can linearly grow. And theoretically, it can support even more of the data size in just one single cube. This one single cube kind of implementation is also very interesting, because when we talk to our clients, a lot of people, they actually have a Cognos implementation or something like that, and they have hundreds or thousands of cubes. Normally, it works in this way. Some people create the cube and then start to support some of the report. And then later on, another requirement comes in with slightly different requirement. Maybe they need to add one dimension or has some different filters or a slightly different calculation of some derived metrics. And then people create another cube and then another cube. And after several hundred, people lost track of those. And when there's a new requirement, instead of bothering to get the existing one modified, people normally will just create another job. So finally, it becomes more unmanageable, right? With thousands of cubes and a lot of maintenance jobs, daily batches, hourly batches. In some of our cases, the user even cannot have 1 day worth of data processing 1 day. So they need to wait like T+2, and then they have a monthly job to catch up. So all these things happens. But with Kylin, you can have a single kind of big cube. And then inside it, it actually has layers of different aggregations. We'll talk about that a little bit later. In this way, you actually reduce your maintenance effort. In one of our clients, they actually reduce the whole maintenance team from 10 to 1 because they don't need to maintain thousands of cubes anymore. You just need 1 people to monitor Kylin jobs to build a couple cubes. And then they support the internal kind of queries with sub-second of latency, as you can see all these different numbers. The second one is Yahoo Japan. This is also a very interesting thing. And from my perspective in the data field, if you work in this kind of team, normally I think one of the challenges, you're always a back office kind of team. And the business team, they have their OLTP system, they develop their own model, they meet their own need without thinking about data analytics. And then your analysis, your functions finally only become a reporting system. But I think for the data team to really become a mission critical team, to really embed it into the business, your data product needs to enable the business. It needs to be embedded into the business. That's how you finally become a mission critical team that cannot be replaced. And in this way, I think here is also one thing that for reporting kind of use cases, especially internally, people has higher tolerance, and maybe someday when it's down for a couple hours, it's still okay. But for client-facing or user-facing kind of features, the tolerance is much lower. So you need something more reliable. And for Kylin, actually, it can support such use cases. For this one is Yahoo Japan is actually the biggest kind of auction site in Japan. eBay lost that battle in Japan. And for them, they produce seller reporting, seller dashboard for their users when they log into their storefront on Yahoo Japan. And all these kind of aggregations actually already stored in Kylin and then serve the website. Previously, it took them a long time, about a minute, to load their web UI because the data query at the backend is slow, but now it's more like real time. And in China, we have another use case with the commercial version that the construction bank, that's one of the biggest banks in China, and they have an app for their high-value users to use their phone to check a lot of their bills and things like that. They have hundreds of thousands of users, and they actually query those kind of aggregation data of individual users from Kylin Cube. Because Kylin Cube can be huge, user ID can be a dimension in it, and then you can have a very detailed level kind of aggregation inside the cube. And then the third one is a company also in China. It's a top one O2O company because that market has so many users. So normally once you have a very good business, you have much bigger user population than any other country. So it requires a lot more big data kind of technology to really support their use cases. So for this one, they use their whole internal OLAP analysis for their business analysts are fully on Kylin, and then it's their core OLAP engine. They have hundreds of cubes for different business lines, with different departments, and support many queries per day. And you can see that half of their queries can be done in sub-second, and also 99% can still be done in a very real-time, very interactive way. So here is a comparison of the query performance. On the left side, you can even cannot notice those green bars. Those green bars are the Kylin's response time, or Kylin's latency, and then it's compared to Hive queries. And with the data size, actually, it won't grow much, because a lot of things has been pre-calculated, and it provides this kind of pre-calculation and pre-aggregation, so that your query can be accelerated in a much faster way, sometimes even tens of thousands of times. So you can see that on the left side, our normal way of doing this kind of query through to your original data source or original data storage will be, you find the tables, you join them, you apply filters on top of that, you have aggregations. And now a lot of those steps already being done before user queried the data. And then there's a so-called cuboid that's pre-calculated to support your query. And the query, when it hits Kylin first, Kylin actually can automatically see if this query can be supported by a cube or not, and then reroute some of those queries to your base source if it cannot be supported. And then later on, you can improve your model to include more dimensions or more metrics that your users normally use. Right. So pre-calculation is the key. Data cube, or multidimensional, is not a new kind of concept, right? We just implemented on the newer big data technology, make it more distributed, more linearly scalable, and also much faster. So here we have something called cuboid. As I mentioned, you can have a huge cube in Kylin, and the base is actually the combination of all the dimensions that you need. And then on top of that, we actually choose subset of dimensions that you can build another layer of aggregation on top of aggregation. In this way, a lot of your queries will not hit the base. It will just hit some of the higher level aggregation, so that your queries actually will be much faster. Because in some other technologies, or you use RDBMS or whatever, if you build such fine granular kind of aggregation, you need to balance that, right? Your query sometimes will hit this, but if it got too detailed, too fine granular, the data size can be even bigger than the raw. So that's why with this kind of layer, with this cuboid kind of concept, you can actually have some more customized, more tailored kind of aggregation to meet your need. You don't need to build all the combinations of those dimensions, only those that you or your user will use 80% of the time. And for the rest, they can still use the most fine granular one to still get their result. And you can see that based on that, Apache Kylin's query performance won't deteriorate with the size of the data. And another very interesting thing is that you always have more data. You always have more dimensions. You always have some ad hoc queries. You always have something that cannot be predefined. And in that kind of cases, you don't want your user to really know where is the data and then go to different sources to find your data asset and then query it. You can actually load all your data schemas into Kylin and then build a partial cube for your 80% of the use cases. and for the rest, maybe 10 or 20%, your user, or the unexpected ones, your user issue the query, and then it will actually reroute that to your base Hadoop clusters, and then find the Hive table and then get the result there. The performance, of course, will not be that good, but at least it's a single point of entry for your queries, and you can get the results still through Kylin. And all this is actually done by the SQL interface. So that's another thing that Kylin can help, and it's only introduced after 2.1 version. And for Kylin, it actually has a very active releasing. As I mentioned, the company, we maintain a dedicated team to contribute back to the open source version. And the open source community also has other players like eBay contribute to the project. And now we're working on the 2.5 version. And as I also mentioned, the roadmap will be going towards fully Spark enabled. And the community has been also quite active, but we do want to see more and more involvement, especially in North America. And currently we have our email list, but later on we'll try to maintain a better forum online. And I think Stack Overflow already have a tag for Apache Kylin, and you can tag your questions. And if you want to try it, you can download from our website and give it a try. So here's the other information that you have. You can have the Apache Kylin has its own Apache website, kylin.apache.org. That's where you can get your latest release and mailing list and other materials that you need. And for our commercial version that includes intelligence, building the modeling, or consume your query logs and things like that, there's a Kyligence.io. And yeah, that's about the introduction. And as I also mentioned to our host, that this is the first time that we introduce this in such a setting. And if people are interested, we can have our friends in eBay and other companies to share more detailed implementations of how they do it, what kind of use cases they support, what's the performance acceleration they can get, things like that, right? And any questions? For some technical, I know a lot of you engineers, for some very technical questions, we have our solution architect here also can help.
What's the approximate size of the HBase database for average cubing, right? Like obviously you're pre-calculating a bunch of stuff, and that can explode in a very major way. So
right.
How big do you see these on average being?
They are big and small. As I mentioned, the biggest one actually has 4 terabytes in one cube, and that's all stored on HBase. But for others, I think maybe you guys have.
This is actually measures of the expansion rate. So for example, your source data could be 1 terabyte, and your. By the way, I'm from eBay. We use it every day for our internal reporting dashboard. So the question is about the expansion rate of the cube from the source data, right?
Yeah.
Some cases we do see it's actually if you don't tune any modeling, it will
just
blow
explode.
Your mind. It's like 10 times larger than the source data. But once you tune it, and sometimes it's maybe 10% or 20% because it's aggregate. It mostly depends on your most of fine granular dimension. Yes. Yeah.
Yeah. What about cloud support?
Well, the commercial version has cloud, and it's also on Google Cloud and Azure and AWS. Yeah.
Because Snowflake is one more company which is providing data warehouse on cloud. So how do you compare against Snowflake?
We don't do such comparison, but yes, there are similar technologies. I think the commercial version, the goal is more ambitious. It's more like we want to be the single layer for all your data assets, either on premises or cloud, or in your traditional RDBMS-based data warehousing, or your newer Hadoop kind of clusters. So all these things, we have a single entry, and we have the single unified semantic layer, and we build cubes to accelerate 80% of your queries, and for the rest, we handle it automatically for you to reroute the queries. And based on your query, we actually now have a AI augmented kind of modeling to help you to build your cube. And then users' query become different, and then it learns from it, from the query logs and all the behaviors, and then recommend the change to your cube modeling, and then build it from there. Yeah. And the cloud version, you can actually have a trial. We have trial license also. Yeah.
Hi.
Yeah.
Good talk, by the way.
Thank you.
So in your experience, and based on the Kylin query loads, whether it's for building the cubes or for the lookups, how much performance difference have you observed between, let's say, a MapReduce versus a Spark? I know you're sort of all moving to Spark, so just curious about how much is the difference in.
I heard it's 2 or 3 times better. Yeah, that's our
Spark.
Yeah.
Actually, a couple of questions. So first one is you talk about like basically the query performance, right? Which is pretty impressive. And in terms of the loading data, so what is the loading performance? Because you mentioned, for example, I think at the beginning of the slides, basically you can have maybe 2 types of the sources, right? For example, one from Hive, the other from Kafka.
Yeah.
So when they load the data, so usually when the big data that it gets kind of like a bigger, is it like the loading time will be linear in terms of the data size? So
the initial load, of course, will be a huge amount of data. And then after that, it actually also uses the incremental load kind of mechanisms. And it has its own segments. And then while you're loading something new, it actually builds a new smaller segment. And then later on, once it's built, it merges with some existing ones, and then keep growing and then become older.
I see.
Yeah.
I see.
So a lot of this kind of optimization is built into the architecture.
I see.
For more details, I think our friends can.
One thing I can add. So there's you asked about is the loading time will be linear. Yeah. So I think the build engine is kind of scale. So for example, for your 1 terabyte source data, you load it for 1 hour. 1 petabyte won't be 1,000 times. It will linear scale if you provision more resource to build it, to join the build, right? Yeah.
So, another quick question is basically looks like there are other kind of like similar technologies out there. For example, like a Druid is another technology that people use for this kind of use cases, right?
Yeah.
Did you do any comparison?
Internally, I think we did some comparison, but I don't use that comparison. I use my own experience. In my past company, I used Druid for 3 years, actually. And in another team of my company, they also use Kylin for a POC. So I think the difference is Druid is very good in the data that's time series, right? Because my previous company, that use case was about game events. And then later on about marketing, mobile marketing clicks and installs, this kind of streaming kind of data. It never changed, and it always just generated in real time and then loaded. So for such use cases, Druid is a perfect solution. I really liked it, and our platform really worked very well. But to make it more like a enterprise level OLAP engine, I think it missed some of those things. And because later on, when we had another use case that needs the so-called cohort analysis, which means like for today, all these users that install this game, I need to monitor their progress. I need to monitor their behaviors. Then the primary key or call or whatever becomes that cohort date, not the timestamp of all these events. Later on, they do this, do that, they buy this, they fight with another player. All these things, you can have more like what's going on kind of analysis with Druid. But with any cohort analysis, it's very awkward to use it. And we actually did a lot of things to enhance that, to even create a new column. And we have a deep integration with superset, because superset use Druid. And then superset, we even have a more time dimension kind of thing to use that pseudo time series. But it's very awkward to use. And it has its own limitation. Yeah. And I think previously Druid only supports the hyperlog kind of count distinct, and you cannot choose the precision that you want. Kylin, I think it actually had the drop down. I saw it somewhere that you can choose to be more precise or less precise, or even do just the precise one without edge. Oh, okay, cool.
Any more questions? Okay, I think we can wrap up.
Great, thank you.